Hello everybody, welcome to our today's Tech Talk about Structural Enterprise. Myself Surojit Ghosh, Senior Structural Engineer at Bentley Systems, and along with me I have Biswatosh Purkayastha, who is an expert in STAAD and RAM products. Today we will demonstrate various structural products comes under Structural Enterprise license and discuss about the complete workflow and interoperability offered by these products to complete your entire project more efficiently. Before that, let's see what we are going to discuss today. First, I will discuss about what is structural enterprise and how this can be used and beneficial over the project delivery cycle. Next, I'll cover the products offered under structural enterprise license and the overview of each of these software. And finally, I'll demonstrate the complete workflow of two major projects. First one is an elevated metro station building made of reinforced concrete and steel. And second one is a residential cum commercial RCC tall building. In these project demonstrations, we will show how repetition of work can be avoided by easy data exchange between these software. So let's start. As the name suggests, Structural Enterprise License is related to structures and it is nothing but a bundled software suite that covers multiple structural analysis and design software like STAAD, RAM, MicroStran, etc. which are mostly used for any infrastructure project, whether that is a simple frame structure to complex industrial or commercial structure. The first and most important aspect of using structural enterprise is that this provides a complete workflow for any structural projects. As you can understand, by using a single product like STAAD or RAM does not provide a complete solution to design all structural components. For example, like STAAD can perform the concrete design but unable to generate the drafting or detailing drawing. Using Structural Enterprise License, you can start working on your project using a single software and later transfer the structural data to different software for other component design or for generating drawing, the design report or billing document. Using Structural Enterprise License, you will get the flexibility both in terms of usage and variety of software. Also, you will get a cost effectiveness by acquiring ACL rather than purchasing individual product license, as ACL is much cheaper than the cumulative cost of all the software. As Structural Enterprise offers multiple software and each of these software comes with various features, we have better flexibility of selecting products depending on project requirement. We have the option to design structure made of various material like steel or concrete, or that might be timber or aluminum. We can use structural analysis method like linear analysis, like nonlinear analysis, or the pushover analysis or the advanced cable analysis. And also complex finite element modeling and analysis can be done easily using specialized software, which are offered under Structural Enterprise License. First, let's find out what are the products offered under Structural Enterprise License. First, we have the STAAD line products, STAAD.Pro Connect Edition Advanced, STAAD Foundation Advanced, RCDC and RCDC FE. Then we have the RAM line products, RAM structural system, RAM concept, RAM connection and RAM elements. And finally, we have MicroStran and Limcon. More than 10 number of softwares are offered under Structural Enterprise License. Now I am going to give a product overview. What is the capability offered by each of these products? The first product is STAAD.Pro Connect Edition Advanced. It is a 3D structural analysis and design software, and more than 90 international design codes are implemented in this particular software. So those codes can be used for application of loading, that might be used for the design of structure, whether that is a timber structure or a concrete structure or a steel structure. There are several analysis methods that is available in STAAD.Pro, like the linear analysis, the nonlinear analysis, pushover analysis, buckling analysis, or the advanced cable analysis. And it is also great with finite element analysis, so you can just model your finite element structure in STAAD.Pro, analyze the structure and get the reinforcement data or the desired data plate stress data from STAAD.Pro. And also it has a large section database, so if you are going to use any standard section either from the AIC code or from the Japanese code or from any Indian code like the Tata Structure or Jindal section database, that is already available in STAAD.Pro. And when I am talking about STAAD.Pro, I am not talking about the older V8i version. Rather, I am concerned about the STAAD.Pro Connect Edition version, which offers a more features than compared to the V8i version. Like it has the new ribbon based interface, it has the new physical modeler which can be beneficial to design your finite element structure. It now uses the 64-bit analysis solver, which can use your multiple core processor available in your machine. Also, several new design codes are available along with all the design codes which are included already in STAAD.Pro. Also, it has a great feature called the advanced concrete design, which is beneficial for the design of concrete structure. We will discuss about details when I am going to show my project demonstration. Now comes the next project, STAAD Foundation Advanced. It is a foundation design software which can be used for any type of foundation design, whether that is an isolated foundation up to a complex planned foundation like a tank foundation or vessel foundation. Each and every type of foundation can be designed using this particular software. It has a great interoperability with STAAD.Pro. So if you model your superstructure in STAAD.Pro, you can easily transfer your support reaction in STAAD Foundation for the foundation design or with any ISM enabled software. Also, you can just export your data from Excel to STAAD Foundation directly. And once you have performed the design, it will provide you a detailing drawing, it will provide you a design optimization, and also it will provide you a calculation sheet with all the reinforcement details. RCDC is another software which is used for the concrete design, whether any type of concrete element can be designed using RCDC like the beam or column or slab, or partially some of the foundation can also be designed in RCDC. One good feature of RCDC is that it automatically detects the physical member from the analytical member. Means if you have already created your superstructure using some analytical member, it will auto-form the physical member for you. Also, it will generate the detailed drawing once the design is completed, the detailed plan, elevation and cross-section drawings, and not only that, it will also generate the bar bending schedule. So once you have performed the design for beam or column, it will automatically generate the bar bending schedule for you with a .dxf format. So you can just directly save the CAD file from this particular BBS. Now comes another software which is called the RCDC FE. It is basically a finite element design software. If you have already created your slab or mat foundation using finite element meshing, you can directly design those slab, elevated slab, mat foundation using this particular software. This is a finite element software which can perform the design for slab system, elevated slab system, and mat foundation. And not only that, it will also generate a detailed drawing. It will provide a good visualization, and also it will generate the bill of quantity for each of this type of slab system. Now comes the RAM line products. The first product is RAM structural system, and this is one of our best solution for building structure, whether that is a simple building structure, probably with G+10 story structure, up to a super tall building. So for super tall structure, the system is something different from the normal structure, like we have the bundle tube or tube in tube structure. We have different framing system. Each and everything can be handled and designed using the RAM structural system. It is both good with steel structure and concrete structure. It has two separate framing system, lateral framing system and the gravity framing system. And not only that, it can automatically simulate the wind tunnel test data. Means if you have performed that wind tunnel test data, you can directly input the data in RAM structural system for the application of loading. RAM structural system has basically 4 modules: the RAM steel, RAM concrete, RAM frame, and RAM foundation, which are used for various part design of a steel structure or for a concrete structure. Now comes the RAM concept. This is our best solution for slab design. Any type of slab system, whether that is a reinforced concrete slab, whether that is a post-tensioning slab, or whether that is a hybrid slab, some part of which is RCC and some part of which is post-tension, can be designed using this particular software. So it is very good with any complex type of slab system, and with finite element analysis has been performed in this software. And not only that, it has some great features like the tendon optimization, like the load history calculation, like the cracked section consideration, and also the footfall analysis. Mainly for any complex commercial structure like a multiplex or like a shopping mall, it is necessary to analyze the slab using the footfall for each person. So using RAM concept, you can directly apply the footfall load, and using that footfall load, it can perform the design for the slabbing system. Now comes the connection design software. For any steel connection, it can be designed using the RAM connection software. It has a direct integration with STAAD.Pro and RAM structural system. So if you have performed your superstructure or the steel member design in this software, you can directly export the connection data to RAM connection and perform the design there. It has different type of connection modules which can be used. It will generate, once the design has been performed, it will generate a detailed report. It will generate a very detailed calculation sheet and also a drafting drawing which can be saved in the CAD format. Now comes another software. It is a finite element software which is RAM elements. It can be used for any type of structure design, whether that is a building structure or for a commercial structure. It has some template-based module for the retaining wall structure design or for the masonry wall structure design, and also for the truss design. And it is very good with pre-engineered building structure. Some of the components like the open web steel joist or the castellated beam can be designed in the software. And finally comes other true products. One is the micro stand. It is something equivalent to RAM structural or the STAAD.Pro, where it can design the superstructure using various method and various design codes that are available in the software. And another software is cont, which is basically a connection design software. So if you analyze your superstructure steel structure in microstand, you can easily design your steel connection using cont software. Now comes the first project demonstration. This is an elevated metro station building of 135 meter is the total length of the structure and 33 meter wide, and it is expected that a 6-lane highway will go underneath this particular station building. The bottom of the structure or the concourse level and the rail level is made of concrete, and the top of the structure or the roof system is made of steel. Various products are used in this particular software for the analysis and design. For example, like I have used STAAD.Pro Connect Edition for the modeling and analysis part. For design part, the RCC beam and column is designed using RCDC. The slab system is designed using RCDC FE. The steel member is designed in the batch mode of STAAD.Pro. Steel connection has been designed using RAM connection, and for foundation design I have used the matte foundation and also pile cap foundation. I have used STAAD Foundation Advanced, and for the drawing generation I have used the steel auto drafter. Let's start with our presentation for the first project. This is the 135 meter long and 33 meter wide metro station building. The bottom of the structure is made of concrete, so the concourse level and also the rail level is made of concrete structure. Beam, column and slab system has been provided for the bottom of the structure, and the top of the structure or the steel roofing system is made of I section and also the hollow sections. So I have used different type of steel sections for the roofing system. The bottom portion of the structure is created from the regular beam grid, and for top curved roof structure, actually I have already created the profile in CAD file, and I have imported that particular CAD file to create the circular or the curved roof system using a single line member. Now for the loading part, I need to consider the load of two trains coming at the same time from the different direction. So I have used the moving load feature available in STAAD.Pro. I have provided the axle load and also provided the direction and applied the moving load on this particular slab system. My intention is to check what is the behavior of the slab and beam system during the movement of the moving load. And all the other loads has been specified, like the earthquake load or the wind load as open structure, as the permeability is high for this structure. The load type for each primary load cases has been specified, and the load combination has been generated using the auto load combination feature available in STAAD.Pro. I have used the steel design auto load combination option because I want to perform the design of steel structure in the batch mode of steel design. So the auto load combination has been used to generate these all load combination cases. And for analysis, I have used both the basic solver at the first case, where the time taken as almost 11 minutes, and then I have analyzed the structure again using the advanced solver to compare the analysis time. And what I notice is that the advanced solver is almost 4 times faster than the basic solver for this simple structure, and you can easily understand what will be the scenario for any large building structure. Once the analysis has been performed, the analysis results are available. So all the plate stress results, like the global stress, like the maximum absolute stress or the FD stress value, will be available, and we can easily check the stress results from the post-processing mode, and these stress values will be used in RCDC FE for the design of the plate element or the slab system. And also, once the analysis has been done, we can check how the slab system or the rail level slab and beam system will be stressed when the loads will be moving. So I have already applied the moving load, so I can check the plate stresses, and accordingly I can provide the reinforcement. For steel design, I have used the batch mode of steel design. So I have used the IS 800 code. All the design parameters has been specified, and once the design has been performed, we can easily check the utilization ratio. We can check it in the tabular format, how many number of member failed or what is the failure ratio. We can check it graphically. So for any part of the structure, we can check what are the utilization ratio for each and every member. a color gradient has been specified graphically, and if we want a detailed report, we can just go to the output file where the detailed design report for each and every segments and each and every clause has been specified. For the drafting drawing generation, we have used the Steel Autodrafter mode. This is a new addition to STAAD family. So using the Steel Autodrafter mode, we can easily generate the drafting drawing along with the grid information. So we can select any of the member and cut the section at this particular location and generate the drawing for drafting purpose. We can select the scale. Once the drafting drawing has been generated, all the details of this particular information, the section information has been specified here, and not only that, it will also provide a material takeoff. So the length and area and the weight of the steel sections that is used in this section has been also mentioned there. And not only that, it can also generate the plan drawing for the concrete part of the structure. So we can easily generate the drafting drawing along with the grid information for the concrete structure. The plan drawing and elevation drawing both can be generated, and this drawing can be saved in the CAD format. So we can easily save the file in .dxf format and later print out and provide it to the site pupil. Now coming to the member connection design, we can use the RAM connection mode, which is integrated with STAAD.Pro. Only thing is that we need to provide the load combination cases that we are going to use for the connection design. We can select the connection which we are going to perform, and we can just specify the connection template. There are different design codes that are implemented there. We just need to select the template on which we are going to perform the connection design, and program automatically performs the connection design. It basically uses the basic properties, and if we want to change the connection property for any connection, for example, like if we want to change any connection type or offset value, we can easily done it from here. A very good 3D view and DXF view will be, or the drafting view will be generated from this connection design mode. We can change the material, or whether we are going to perform the welded connection or the bolted connection, we can select it from here. Also, if we want, we can provide the offset value also. And at any time, we can change the design code. So if we start with AIC code, rather we can go for the Indian design code also at any stage. Not only that, it will provide a very good results report. So it will provide for each design clause what is the utilization for this connection design. And not only that, it will also generate a detailed calculation report. So it can be saved in the Word file format. Each and every steps that is followed to calculate or design the section has been mentioned here. And coming to the base plate design, as the steel column section is connected with the concrete section, so we need to perform the base plate connection design. It is similar to the other connection design. Program automatically design the base plate connection, and if we want to modify anything for this connection, we can directly modify it from here. For example, like we can provide the stiffener plates, or we can provide the stiffener channel elements for this connection. And also we can change any eccentricity value for this particular type of connection, or if there is any other type of support system that is present in the structure, for example like a pedestal, that also we can provide it from here. So we have various options available in this connection design module. Now coming to the concrete design, advanced concrete design module, or what we called as the RCDC mode, is used for the concrete beam and column design. So we only need to provide or export the STAAD.Pro model that has already been analyzed to RCDC mode, and we can select from various design code and from the beam element or column element whatever we need to design. For beam design, program automatically from the physical member, from the beam continuity, or it will automatically finds out what is the physical member length, and accordingly it will create auto-form the member. We don't need to provide any information regarding the physical member, and if any member is not satisfied, we can directly change it from this particular window. We need to provide the general reinforcement settings for the beam design. So we can provide the concrete grade, the steel grade, whether we are going to perform the ductile detailing for this particular beam section or not, whether we are going to provide the crack width check or not, that we can provide directly from here. So only thing we need to provide here is the beam information or the design information that is required for the beam design. And also generates the detailing drawing. So we need to provide the detailing drawing information like the development length, or like the whether we are going to provide the anchorage or not, that we need to provide. And all the basic load cases that has been specified in STAAD.Pro has already been imported in this particular segment. So in RCDC, we only need to provide the load type for each and every primary load cases that has been imported in RCDC mode, and program will automatically generate the load combination cases depending on the design codes. For example, like we can use the ACI code or the IS456 code to automatically generate the load combinations in this particular module. And once the design has been performed, it will provide a detailed design information, the reinforcement information, whatever has been provided to the physical member. We can check the design information in the detailing drawing. We can generate a very good detailing drawing, the elevation drawing and the cross-section drawing directly for any particular physical member and for all the members also. So it can be saved, it is exported in DXF format, so it can be saved in the DXF format and further can be modified by opening it in any CAD software. Also, we can generate a very good calculation sheet and design summary from this particular module. So in design summary, each and every member design, how these steps has been followed has been mentioned, and also we can get a very good detailing calculation sheet which can be saved in the Word file format and can be submitted as the design report. So each and every clause that has been followed to design the segment and also the design forces that has been used for the design has been mentioned in the calculation sheet. And not only that, it will also generate a bar bending schedule and the bill of quantities. So for bill of quantities, we need to mention the value of each item and it will automatically generate the bill of quantity. And for bar bending schedule, we need to provide the basic like the what is the member length or the rod length that is available, reinforcement length that is available. And accordingly, it will generate the bar bending schedule. It will provide each and every details for each and every member. So what is the development length, what is the bending length, what is the length of the stirrup, that has been specified in the bar bending schedule. For concrete column design, the same mode has been specified. In RCDC, we have different design codes that has been implemented, and once we have imported the section, we can directly design the column sections in this particular module. We need to provide only the design parameters, and once the design has been performed, it will provide the column reinforcement, what is the percentage of steel that is provided for any section. We can directly check the section for any particular segment of the column. We can, as this is designed from the first principle, so we can check the interaction surface, and if we are not agreeable with any of the sections, then we can edit the link arrangement from this mode directly. And also it will generate a text schedule. It generates a elevation and cross-section drawing similar to beam section. So a very detailed drawing sheet can be generated here. It generates a calculation sheet, and not only that, it has a good feature of creating the failure diagnostic report. Means if any section has been failed, it will provide the clause for which the member has been failed. And finally, it also generates the bar bending schedule for the column member. It provide all the link and link information, the bending length, the bar length, everything is provided in this particular module. So this is a very good addition. Now coming to the slab design, I have modeled the slab or the concrete slab using the finite element mesh. So for that I have used the RCDC FE software. Once the model has been analyzed, we can directly import it in RCDC FE for the slab design. Only thing is that we need to provide the details about the project. So IS456 code and ACI code is already implemented in RCDC FE mode. We need to import the file and we need to inform the program at which level the slab system is present. And once all the information has been provided, program automatically detects at which level the slab presents, and accordingly it imports the section. It has a good visualization, so we can directly import the model and check how the slab will look like. All the load cases and all the information that has been specified in geometry information that has been specified is imported. Only thing is that we need to provide the detailing and design settings. So we can need to provide the concrete grade or the steel grade and the clear cover value, whatever we have for the design of slab system. Once each and every information has been provided, like the reinforcement setting or the general design parameter settings, we need to create the load combination here that can be automatically generated. All the design codes has been implemented, the ACI and the 456, and once the design has been performed, we have the design results. It has a very good visualization, so it will provide the design reinforcement information in graphical view, like what is the required reinforcement. We can check it in the graphical view and check in which zone the reinforcement requirement is high. We can also check the provided reinforcement information, so we can check it in both in the longitudinal direction and also in the transverse direction, what is the reinforcement and how the reinforcement zoning will look like. And not only that, it will also generate a detailed calculation sheet directly from this design report. So you can check it directly from here. We can save it in Word file format, and later you modify and use it for the design report submission. And also it generates the BOQ. So for each and every slab element, what is the cost of the costing of the slab system construction, that can be generated from the bill of quantity. And finally, it generates a detailed drawing. So if you want to check the detailed reinforcement drawing and GUI drawing for any slab system or part of the slab system, it can be directly generated from this particular RCTC FE mode. So it generates the detailed drawing, and this can be saved in the CAD file. Now coming to the foundation design mode, we have the STAAD Foundation Advanced software which is integrated with STAAD.Pro. We can use this for the foundation design. We only need to export the primary load case information, and once the information has been exported, all the support reactions has been included in STAAD Foundation. Only thing is that we need to generate the service and ultimate load combination cases in STAAD Foundation mode, which is inbuilt, so we can directly generate the load combination cases in this particular module. In STAAD Foundation Advanced, we need to create the job on basis of our requirement. For this example, I am going to create a pile cap job with several supports that are available following the Indian design code. So once the job has been created, we have the settings for this particular job. So we have the pile cap job available, and we can provide the necessary changes. We can provide the pedestal information. If there is any pedestal available for this pile cap, we can provide it directly from here. For design parameter, we need to specify the soil parameter and the reinforcement information that is available. So we have the report, and we can provide it directly here. And the pile arrangement is automatically determined by the program depending on the pile capacity that has been specified. So we have the support reaction value, we have the pile capacity value, and program automatically suggests what is the suitable pile arrangement. And if we want, we can change the pile arrangement for each and every pile cap job. So if we can directly accept the pile arrangement that is suggested by the program, or we can select our own pile arrangement, and depending on that, program perform the design. And once the pile cap design has been performed, it will provide the design reinforcement information in calculation sheet format. So you can get a detailed report for the design information, and also tabular format output is provided. And not only that, a detailed and scheduled drawing for each and every pile cap that has been specified, which can be exported in CAD format, and also a GA drawing has been specified where we can check if there is any problem with the foundation or not. And finally, if we want to check the reinforcement details, we can directly export the segment in ISM format, and in ISM format we can check how the reinforcement has been provided. So ISM has a great interoperability with any of the Bentley products, and if we export the section in ISM, we can check it graphically, the reinforcement information, and also how the structure will look like, or how this will be looks like, how the reinforcement will be placed in the structure. And not only that, if we want to check the information of any reinforcement layer, we can check it directly from here. Means if we want to check how many number of bars has been provided in a single layer, we can directly select the layer, and at the left hand side of the screen we will get the information of this reinforcement layer. And similar fashion, we can export the overall structure to ISM for the visualization. For example, like we have the fly and walkthrough view available in ISM, so I have directly exported the section, the whole structure in ISM for the visualization, where I can check easily how the structure will look like. And if we want, we can just publish it in iModel format and check it in the structural navigator by some mobile application. So this is all about the first project. Now I am quickly going to the second project. Second project is a building structure. This is a 42 stories high residential cum commercial building, and there is a 3-story podium that is constructed at the bottom of the structure. Various products as structural products has been used for the design and analysis of the structure, like the RAM structural system is used for the modeling and analysis. And for design part, the RCC beam column is designed using RAM concrete, and also we have designed the shear wall system for this entire structure using the RAM concrete. And the slab system has been designed using RAM concept. And the foundation design, we have used the STAAD Foundation Advanced software. Now Biswatosh will demonstrate about this project study in more details.
Hi, this is Bishwa. Before going into the model, let's quickly see the different modules within the RAM structural system. First, the RAM modeler. This is for modeling the structure and its geometry. Then RAM steel beam. This is for designing gravity steel beam. It is a very powerful tool for composite deck design. Then RAM steel column. This module is to design the gravity steel column. Then RAM frame. This module is the cornerstone of the RAM structural system, as this one has the finite element analysis solver where you can set various complex analysis criteria. Then RAM concrete. RAM concrete is for designing various concrete elements like beams, columns, and shear wall. Then eventually RAM foundation, which is a very powerful tool for designing the foundation. Okay, so let's take a look in the model. This is a 42-storied residential cum commercial building. As you can see on the screen, I am just rotating around. So the entire building has 3 levels of commercial space having the podium levels, and these are the different story levels you can see here on the screen. Now the first two commercial space levels are for the shopping complex. Now I have also included all the different elements like shear core and its opening. Here in the model, you can see that I have already created different floor plans. By this, I have the flexibility to assign the required floor plans to the intended floor levels. For modeling the various floor plans, I can create two coordinate systems. First, the rectangular grid system. Second, the radial or the circular grid system. This helped me in creating both the polygonal and the circular profile of my floor plan. However, if you have any integrate floor plans, then you can directly import the same from any external source via DXF format in the RAM modeler. Now the central part of the column arrangements in this diagram are depicted in blue colors, which denotes the gravity members, and most of the members surrounding the periphery are the lateral members. Now, the RAM structural system has the unique capability by which an engineer can assign a member as a lateral or a gravity. The lateral framing system is for handling both the lateral and the gravity load, and the gravity members are for handling the gravity loads. This is a very useful feature. By this, one can optimize the building structure judiciously by assigning the proper framing system. And this is a very powerful tool for modeling the tube structure like tube in tube, bundle tube, as you can see in the screen, whose peripheral members are designed mostly by the lateral members and the inner part as the gravity member to optimize the space within the inner zones. Now, this is a very famous building, the Shard, London. As you can see, one of the floor plans is shown on the screen. This structure has been designed in RAM structural system. Now you can see that all the peripheral members are assigned as the lateral framing system. The RAM structural system has the option to define the concrete, composite, and the non-composite deck system. The program has a very advanced capability to handle the composite deck slab. Now, in this model, I have only used the concrete slab. Now, please note that these floor decks are the finite element model of the floor systems, so there is no room for any approximation. Now, let's quickly see how I have created the floor slab by a simple example. The program has a quick tool by which one can create the entire floor deck in a single click. All I need to do is to provide the overhang portion with some value. In this case, I have used a 300 mm of the slab traversing all across its periphery. Now, the program recognizes the external closed boundary and accordingly generates the floor. Now, as this floor has the shear core, so we need to also create the opening in the slab. Now, this can be very easily done by clicking on the in bay option. See here, I have just clicked in the respective panel and the hole has been automatically created. I have used this technique to quickly model all my floors. I have used different types of loading like surface loads and the line loads. The surface load is for the pressure intensity and the line loads for the external and the internal wall loads. Please note that here for the line load, We needn't have to provide any dummy beams because here the linear loads are applied directly on the floors. See here, I have an octagonal shaped line load representing the portion of the line load from the kiosks. Now, being this the podium level floor, so I have used only the flat slab, and hence I have added the drop caps and thickened some other portion of the slab. Now the interesting part here is after providing the drop cap, the slab thickening is not done along both the opposite surfaces of the slab, but the thickening is generated along the downward direction for capturing the true effect of the element as it is supposed to be in the practical scenario. Now rest of the floor plans have the regular floor geometry with beams, columns, and slab. You can see here the two identical floor plans of the twin tower which has the regular beams. Now I am selecting one of the shear walls in the model. RAM structural system has an advanced capability to model, analyze, and design the concrete shear wall. Program gave me the option to define the desired opening and its location in the lift core. Once I'm done with modeling the floor plan, I could generate the three-dimensional geometry by generating the required story levels. Here you can see I could assign or map the desired floor plans to the desired story levels. Anytime you can change this mapping without remodeling the entire structure. This is the view of another floor plan where I have added a swimming pool load. As this imposed the partial load intensity, I had to provide the partial surface loading on that portion. This can be easily done in the RAM modeler. The quick way is by using the construction line. In case you come across a situation like this where the boundary node of selection doesn't coincide with the regular grid, then you can add the intermediate grid line dynamically. I could switch it off later on. This facilitates me to select the intermediate nodes for creating any shape of the partial pressure loading or the line loading. Now let's take a closer look of the meshed slab and the shear wall. Please note that RAM structural system models the structure as a physical model, and hence the analytical model like the meshing of the plates are automatically generated by the program maintaining the proper aspect ratio, considering all the control points. See here how nicely the internal columns are considered as the control points. One can also change the default mesh density. Now, this physical model approach is very useful from the practical standpoint. We all know that the designer has to work with their clients and the architects who over the time make the changes in the structure depending on various user requirements. But this is very painful for a structural engineer to amend those changes in the model. But with the physical member approach, a structural engineer needn't have to worry much. Let's take an example. You have been told to change the location and the dimension of the opening in an existing shear wall. As the plates are already meshed, had it been the analytical model, it is very difficult to make the changes as we might have to delete the entire meshing and redo the modeling with new geometrical information. But here, being a physical modeler, we can make these changes anytime without any hassle. Just carefully see the meshed pattern before and after the changes. Program finally optimizes the meshing. Now let's quickly move to RAM frame. As here you can apply the lateral loads and also you can define various analysis criteria. Let's discuss few of the salient points here. First is the rigid end zone. You can see on this table. This is for capturing the true effect of the infinitely high junction stiffness or the rigid end zone. Now, if you see this figure, analytically we consider that bending starts from the center of the member, but in reality the stiffness from the center line to the member face is extremely high, so that these portions insignificantly bend or deform in comparison to the rest of the member. So in short, the bending actually starts from the face of the junction. So to capture this effect, one needs to analyze the structure with the reduced length. This reduced length can be defined in RAM frame by rigid and zone. One can define the reduction value in the box. One means infinitely high rigid and zone, so 100% reduction. The next is the response spectrum. The RAM frame can handle the dynamic analysis like response spectrum analysis. The good news is one can get the sign in final overall response quantity. This sign is taken from the sign of the dominant mode and apply it to the resultant response quantity. This is very useful as in the general response spectrum analysis, the sign is lost due to the presence of the square and the square root term in the combination pattern like SRSS or CQC. But the idea of sign is sometimes very important for optimizing the design like footing design or when combining the static case with the dynamic case. To avoid this limitation, we can use this sign response spectrum option. The next is the eigenvalue analysis. Now the program has the advanced capability to handle the eigen solution needed for determining the modes and its corresponding Rachel frequency. There are three different methods available. First, the conventional eigen solution by subspace iteration. Second is the Arnoldi-Langzos. This is a very powerful algorithm and it is sometimes very useful when solving the complex model like this one with huge number of plate elements in conjunction with the p-delta analysis. Third one is the Ritz analysis. This is a very interesting part of this eigensolution methods. Now let's take an example as shown here. Imagine if you have a mezzanine floor or a steel deck or an antenna model in the structure whose stiffness is insignificant in comparison to the main structure. Then after conventional eigen analysis, we might notice that the first few modes are the local modes like this, see the picture. And these local modes carry insignificant mass participation factor. Thus, we end up getting a very low cumulative mass participation with the default cutoff modes. But as per the codal requirement, we need to consider at least 90% total mass participation. So you might have to stress your computer by requesting higher cutoff modes. However, the Ritz analysis can cut this problem short. This method generally captures all the modes having significantly high mass participation factors, and thus you will end up reaching the 90% target with fewer number of modes. Now, other advantages of this Ritz analysis are like Ritz vector solution is faster and require less memory than the traditional eigen solution method. And Ritz vector automatically considers all the residual modes of the structure, so you didn't have to do the missing mass consideration after you do the traditional analysis. Now the P delta analysis. This is very important for the tall structure like this one. Now, when we talk of any tall structure which is subjected to the lateral force like earthquake, ground excitation, then the P delta effect gets significant. Thus, one has to perform the analysis which captures this second order effect. But the challenge here is performing the non-linear iterative P delta analysis in conjunction to the dynamic analysis. But here we have implemented a very powerful feature where you needn't have to perform the complex iterative P delta analysis. You can use the geometric stiffness method to reduce the total stiffness in a single go by introducing the kg matrix and thereby performing the P delta analysis in a non-iterative way. The advantage here is in the absence of the non-iteration, we could easily perform the eigen solution in conjunction with the P delta analysis. Now, please remember that this method is very effective for the building like structure only, where you needn't have to unnecessarily employ or use any other numerical efforts. Now, in addition to this, you can also control other analysis settings and parameters like using different types of solvers, as you can see here, changing mesh density. Then if you are performing the steel design in RAM frame, then you can use this reduced stiffness option as per the direct analysis guidelines per AISC code. Now, Let's see few of the lateral loading options in this program. I have defined the wind load in this structure. Uh, First, please note that recently we have added a wind tunnel test loading option in RAM frame. This is very useful for the tall structure which demands the rigorous wind tunnel test results. And for the tall structure, designers generally prefer the wind tunnel test result rather than the conventional wind load prescribed by the code. So you can directly get the information from your engineers who perform the wind tunnel test and feed those values in the wind tunnel test loading. However, in the structure, I have only used the code-based wind loading. Uh, Defining the wind loading is very simple here. It is a one-click wind load generator. All you need to do is to define your parameters and program would generate the loadings in all the four directions. The same is for the earthquake loading like equivalent lateral loading or the dynamic analysis like response spectrum analysis. Uh, the same way I have applied the loading with all the parameters for the static and dynamic earthquake loading for the structure. And finally, I have defined the load case for the construction stage analysis that I'll be discussing very shortly. Now, the beauty of this software is that you needn't have to run all the load cases every time you make any changes in the model. You can selectively perform the analysis against the selected load cases only. Now we will see various options to define the diaphragms. As this software is meant specially for the building structure, we have incorporated various types of possible diaphragms in the real life scenario. First, the rigid float diaphragm. It is a type of diaphragm which considers an infinitely high in-plane rigidity, which has only 3 degrees of freedom, two laterals and one in-plane rotation. Two laterals mean in-plane lateral direction. Semi-rigid, it's like mashed plate elements which can undergo out-of-plane bending and doesn't have infinitely high in-plane rigidity. Uh, Flexible diaphragm. The flexible diaphragm doesn't have stiffness but able to transfer load just like stretched fabric. Pseudo-flexible. This is a very interesting and differentiating feature of diaphragm in RAM structural system. For this, let's refer to various codes like ASC or the Indian design code, where it mandates that the building is analyzed or should be analyzed as a dual diaphragm system, and the design is to be performed in such a way that the moment resisting frame should be strong enough to withstand at least certain proportion to the lateral story shear. For example, in the Indian design code, it is around 25%. So the pseudo-flexible diaphragm, by this feature, one can allocate the required proportion of the story shear as per your code uh, to the frames and perform the allocation analysis. Now, another key feature is the construction stage analysis. And this is very important for the tall building like this. Now, the building is constructed in a sequence, but we analyze them as if the entire building is casted or the dead load has been applied in a single shot. But this is not the real case. In the real life scenario, once the construction of the floor level is over, it is exposed to certain period, and on top of that, loading from the story above is transferred to different types of props and shoring to the lower floor levels. And due to this, the lower floor undergoes certain geometrical changes and the load paths. These changes is fairly magnified and noticeable once the number of stories gets higher. In addition to that, you have to also consider the different time-dependent effects which undergoes in various stages like creep and shrinkage. So it is very important to capture the actual response of the structure to avoid certain failures behavior like column shortening effect, as you can see on the picture. I have defined all those parameters needed for construction stage analysis like duration of each stages, then the material property and so on. Now I have performed the analysis and now you can see various post-processing results like deflection and then mode shapes. Here you can see on the screen. These are the mode shapes according to my selection. Lateral mode. Now this is torsional mode. I can also view the different post-processing results like deflection, member forces, and etc. You can see the post-processing result also in the report format. Now let's see one of the post-processing result here. You can also see that the program is also able to report the center of mass and the center of rigidity of the individual diaphragm of those individual towers. This is very helpful to know the actual torsional behavior of the individual diaphragm. So this is a very key differentiating feature in the program. Now we can move to RAM Concrete for detailed designing of concrete element like beams, columns, and shear wall. Let's start with concrete beam. Here program designs the beam as physical member, so we can automate the formation of the physical member or the beam line, or we can manually select them. After this, we can define various design parameters with the respective design codes. So in this model, I have selected the latest ACI code. Here I can choose various sections that I've already predefined in RAM modeler and design them without reanalyzing the structure. Now remember that this is very powerful feature, and this helps the designer to quickly assess the right section before finalizing and running the final analysis. So you needn't have to reanalyze the structure over and over again once you make any changes in the sections. I have created the load combinations by the auto load combination rules as per the selected code. Now you can see here. However, you can manually make your own custom load combos. Now I'm running the analysis. You can see that the analysis status in different colors, which depicts the demand versus capacity ratio, which helps the designer to quickly identify the critical beams. Now, after the design, select any beam line where you can view the design output like actual versus provided reinforcement graph. You can make any changes in the bars to dynamically see the design results if you are happy with the manual adjustment. If you're happy, then you can update that changes and assign it to the member. However, you can anytime roll back to the program suggested design result by just clicking on the optimize button. And eventually I can see the complete design in the report format where it will deliver me all the informations like what are the equations involved while performing the design, which is the most critical load cases, and so on. Now, the similar way I have designed the columns. The column design is also based on the physical member based design. One more additional option here is one can define the different bar arrangements, and the program would choose and check all of them and design with the most optimum bar arrangements. Now finally, the shear wall. The shear wall is the vital structural component in the tall structure like this, and one has to design them very effectively. Now the RAM concrete has the advanced capability to design the concrete shear wall. Here one can design the shear wall as a group, just like the shear core, or design the individual wall elements separately. After defining various design parameters, I have performed the shear wall design. And important elements of the shear wall is the coupling beam, especially in the shear core like this, where there are several openings. Coupling beam is very important when there is a differential movement at the interface of the opening due to the lateral load. Now let's design one of the shear core. I have selected one of the shear core, and now let's perform the design. Now after designing, you can see there are different levels of outputs. Now in this dialog box, you can see the different types of outputs like reinforcement information, interaction curve, and so on. You can also get all those design in the report format, just like we have seen in the beams and columns. Although I haven't considered another important elements in the shear wall called boundary elements, but the program has the ability to design the boundary element very efficiently. A snapshot of one of the boundary element I have taken from another model you can see on the screen. Now I am exporting the podium level floor slab to the RAM concept and will perform the detailed designing. You can see here the three-dimensional view of the entire floor. See the drop caps and the thickened portion of the slab. The loading information has already been imported, although I can have the chance to make any changes here. Now, this module is a complete finite element module and hence you can control the meshing very effectively. The designing is based on the strip method where it averages out the force values within that zone to deliver you the most efficient and optimum design result. So the first step is to generate the spans in both the directions. You can control the default settings. Next, I will generate the strips in both the directions. If the slab is complex in shape, then you could fine-tune it by manually reorienting and trimming the strips. Now, the punching shear is a very important part in the slab designing, especially the flat slab like this. Now, program generates the punching shear zone with the default radius and it can handle the punching shear check very effectively. However, I can make any changes with the default radius. Also, you have several other options by which you can set other design criteria like selection of rebar diameter, rebar grade, concrete grade, and so on. Now I am firing the design. Once the design is performed successfully, we can view the rebar information in various layers. For example, the individual top bar plan. You can also have the detailed perspective view of the overall rebar plan. This provides you a better idea on the overall rebar arrangements. Now, there is a quick tool which can provide you the estimation of different types and its quantity of material required. Please be noted that in addition to the regular slab, program is well equipped to perform the advanced post-tension slab design. Currently, we have also implemented tendon optimization feature which will suggest you the most optimum tendon layout profile. Also, RAM concept provides two other important analysis tools. First, the load history analysis to assess the time-dependent effects like creep, shrinkage on the slab. Second, the vibration analysis. In the load history analysis criteria, I can provide different material property information and perform the load history analysis to know the different types of deflection like maximum short-term, sustained, and instantaneous deflection on the slab. Now the vibration analysis. This is a very helpful tool to simulate the footfall analysis on the floor due to large number of unique footsteps and its corresponding frequency imposed on the public space. By this, we can understand the resultant vibration of the floor along with the detailed information like mode shapes and its natural frequencies. So with this, I'm concluding my session here. Thank you very much to every one of you and see you again. Take care. Bye.